All right, let's look at proposition 2.2.3. It will tell us how to prove that a linear transformation is one-to-one. All right, so let V and W be vector space and let T from V to W be a linear transformation. Then T from V to W is one-to-one if and only if its kernel, that's a subspace, remember? It's the smallest possible subspace of V. It's just a zero element. All right, so let's prove this. I'm going to start by assuming that T is one-to-one. And then I'm going to take, well, we can say that 0 of V is, T of 0 of V is 0W. That means 0 of V is in the kernel. Well, that was a bit obvious because it's a subspace, but I want to use this because I'll use it again. All right, so that means I've proven that this set is inside the kernel of T. And then I want to prove the opposite, so I'm going to take an element V in the kernel of T. I want to prove that it is the zero element. All right, so TV is 0. That's what it means to be in the kernel. But that was the same as T of 0. All right, so V and 0 are both sent to the same element. But since T is one-to-one, T of V equals T of 0 of V implies that V equals 0 of V. Right? If two elements are sent to the same one, then they're equal. And so, what do I want to say? And so V0, and so wait, kernel of T is actually 0 V. All right, so that proves one direction. Let me prove the other one. I'm sorry, I was choking a bit. So let's assume that the kernel of T is 0. I want to prove that T is one-to-one. All right, so I'm going to take two elements of V that are sent to the same one in W. Right, so we assume that they're sent to the same one, and we want to show that V1 equals V2. All right, so let's start. T of V1 equals T of V2. That means that if I look at T of V1 minus V2, I'm going to get T of V1 minus V2 because T is linear. All right, so this is where linear helps us. And since these are equal, I get the zero vector in W. All right, so V1 minus V2 is in the kernel because it's sent to 0. But the kernel is just 0V. That means V1 minus V2 is 0V, and that means that V1 equals V2. Right? You just add V2 to this side. All right, so I started with any V1, V2 that had the same image, and I proved that they were the same. That's what I need to prove to show that I have a one-to-one map.